Good morning, Tahmina Khan is here in TKMaths S1. In today's video, I will explain to you a concept of integration by substitution. It is a part of the syllabus of A-Level Mathematics, Paper 3, Code 9709. To explain this concept, I have taken a question from March 16, variant 3 to question 5. So before we begin, you can see on the top my website address, tkmaths.com, and my blog address, tkmathsisfun.blogspot.com. All my videos I have made so far are available here on my blog site and on my website. Website has more options. It is offering online classes. It is offering short courses. It is providing checklist for exam preparation and many more. It is still under development, but still you will find a lot here. So let's begin with the question. So this integral is given to you 9 divided by 3 plus x square dx, and substitution is given to you root 3 into tan theta. So you have to do this substitution and you have to bring it into this form. If you notice here, things were in x here and they are in theta here, right? And the second part is, after proving this, you will integrate it. So let's begin with this. So now this is a question given to you, and x is equals to root 3 tan theta is the substitution. So this is you will use to change x variable into theta variable. So now you will differentiate it first of all, and then applying the separating the variable concept, you are separating dx. So it will become root 3 sec square theta d theta. The whole purpose here is that x and dx should change into theta. So whatever the substitution is given to you, you differentiate it to replace your dx, right? And then x will be replaced by root 3 tan theta. So what it will become? 3 plus, because if you square this term, x square, it will become 3 tan square theta. So that's why I've written it here. And dx I am replacing by this. Now, do you notice any mistake here? I have done it intentionally to see if you can notice or not. Yes, this mistake is, you see the limit here is 1 and 0, and same limit I'm writing here. So when you change your variable x into variable theta, your limits will also change, right? And how it will change? Using this substitution. So let's see it here. Now, the substitution thing is given to you, x is equals to root 3 tan theta. So when your x is 1, I want to see what this will become. So when x is 1, this equation will become 1 equals to root 3 tan theta. And then you are bringing it simply here and applying trigonometry, basic angle. Answer is tan inverse 1 over root 3 is pi by 6. So 1 will be replaced by pi by 6. Now let's substitute 0 here. So when it is 0, equals to root 3 tan theta. So 0 divided by root 3 is 0, and tan inverse 0 is 0. So this one will remain 0. So now I have substituted the limits here, and 9 multiplied by root 3 I have written outside because it is multiplying. So multiplier can go outside the integral, it won't make any difference. And then from the denominator I have taken 3 common out. Can you notice this thing? So it will be 1 plus tan square theta. I have used different color to make it more prominent. Now if you remember the identity, what is 1 plus tan square theta? Do you remember the identity? 1 plus tan square theta. This identity you need to know. It is equals to sec square theta. So I will replace it by sec square theta. And this 3 can go out. Sorry, this 3, because it is a square, it will become 9. So 9, and this is tan square theta, and this square outside will come here, right? And 9 is cancelling with 9. So now this sec square theta, I can cancel with this, and I will be left with what? 1 over sec square theta, right? And what is 1 over sec square theta? Do you remember? Yes, it is cos square theta. And this is what you had to prove or shown in the part 1. So part 2 was showing now integrate this. Okay. Mostly children make mistake here because in integration there are different type of cases. If you want to see in detail, I'll attach the link in my description here. So you can go to that description, or you can go on website or blog address, whatever you like. So whenever you have to integrate cos square theta or sin square theta, you take the help of double angle formula. Now see here. We know cos 2 theta is equals to cos square theta minus sin square theta. Or it is 1 minus 2 sin square theta. Or it is 2 cos square theta minus 1. All this will be given to you in MF19. You don't need to learn it by heart. If you don't remember it, it's fine. So now cos 2 theta equals to 2 cos square theta minus 1. This one will help me to get cos square theta out of it. So I'm just manipulating it, keeping this term separately, bringing 1 here, and then dividing by 2. So cos square theta I will replace by cos 2 theta plus 1 over 2. Okay. So even if it is sin square theta here and you have to integrate it, please use the same identity, and this side it will be cos 2 theta equals to this. Then make sin square theta subject and then substitute here. Right. Anyway. So now I can take 2 outside. Okay. And we know integration of cos 2 theta is what? Do you remember? Sin 2 theta over 2. And plus 1 will be theta. So after integrating this, now you will do upper limit minus lower limit. So first I am substituting upper limit in place of theta. You can see in blue. And then I'm substituting 0 in this whole function. Right. So after that, cancelling, and it is sin pi by 3. Use calculator to find out the answer. And question is saying very clearly, give your answer in exact form. So when it is saying exact form, it means do not write in decimal at all, right? Keep pi in terms of pi. So and after this, I'm simply simplifying it, multiplying this by this and by this, and you will get this. So this is your exact answer of the integral. Integration of that function cos square theta with limits 0 to pi by 6. So I hope you have learned something from this video. Please press like and subscribe button if you want to see more videos, and if you want to encourage me, please press like and subscribe button, share it with your friends. Your positive comments will encourage me to make more videos. Take care. Allah Hafiz.